Today we're here in Espirito Santo at ArcelorMittal a steel plant, to show you how they produce fresh water using seawater. What? Wait, I'll explain soon. Want to check it out? It's hard to imagine, but water is essential in steel production. The steel industry wouldn't exist without water. Here at ArcelorMittal, they turn iron ore into steel, and for that, they use 3 blast furnaces. These are huge, super hot furnaces. And because of that, they also need excellent cooling. Just so you have an idea, if one of these furnaces needs to be shut down, though the whole process takes about a month, and to turn it back on, it's not just a matter of pressing a button. It needs maintenance that takes about 3 months. So, controlling the temperature is really important. Come on in. Hearing that, you must have already thought about the amount of water used in this process. And the concern you're having right now is the same one ArcelorMittal had when they implemented this water desalination process, which is removing the salt from seawater. Actually, since the 1980s, a good part of the water they use in their processes here already comes from the sea. It's collected, used in the cooling processes, and then returned. But there are some processes where the water can't be salty, either because it's going to come into direct contact with the water that's produced, or because it degrades the pipes. And this idea of removing the salt from seawater was only possible because here they are self-sufficient in electricity. Yes, they have thermoelectric plants that make use of the gases generated in various processes here at the steel mill.
The benefit is greater water security, both for the company in times of crisis and for society. It brings the benefit of providing security for the company's production process, but also for society in times of water crisis. Since you don't take this water from the available water resource, which is the Santa Maria River, this is the first desalination plant of this size in Brazil.
There are several techniques to remove salt from seawater. You've seen us on Manuel do Mundo try distillation with bottles, but the process here is different and starts with water intake. It comes through a channel that's about 500 meters from the coast, and it's been there since 1983, already serving some cooling processes. There are electric pumps that pull this water into the factory's piping. One of the first things the water will receive is a coagulant additive. It's used to gather the dirt, forming larger particles, which makes it easier to filter. In the first stage, the water will go through these filters here that block particles up to 100 micrometers in size. That's 1/10 of a millimeter, just a bit thicker than a strand of hair. In the next stage, ultrafiltration will take place. There are 294 tubes like this, and inside each one, there are lots of tiny microtubes. They're capillaries where the water flows through and leaves the dirt behind. It's so powerful it can filter bacteria and even viruses. If we cut one of these tubes open, this is what you'd see inside. The water has to be this clean because in the next stage, which is reverse osmosis, there can't be any solid particles. But before we get there, what is osmosis after all? There are some membranes, a kind of filter, where we can make the water pass through, but not the salt. And this exists in our cells, for example. Here's a drawing of one of these membranes. If on one side of the membrane we have salt water, and on the other side, water without salt, the natural tendency is for the fresh water to move to the side with salt until the concentration balances out, until the salt concentration is the same on both sides. That's why when you season a salad with salt, for example, the lettuce starts to wilt because its water starts to leave to balance things out, moving to the side with more salt. But wait, if there's a membrane that lets water through but not salt, couldn't we use that to do the opposite? Take water that already has salt and make only the water pass to the other side. That's exactly what happens here in reverse osmosis. By applying pressure to salty water, you get salt-free water on the other side.
For us to be able to remove the salts from the already ultra-filtered seawater, we're going to need a lot of pressure to get only water through a semi-permeable membrane that keeps the salts on one side, leaving desalinated water on the other.
Reverse osmosis is happening inside these white tubes. Inside, there are some membranes. The water passes through them and then flows through the middle. So, In the middle, we'll have water that's practically desalinated. It has less salt than the water we drink. And on the outside, we'll have brine coming out, which is super salty because it's carrying all the salt that was removed. If you're curious, they have a cut membrane here. I used to think it was like a coffee filter, but it's more complex. The brine still comes out with a lot of pressure, and it would be a huge waste to just release this brine and waste that pressure. So what do? The brine goes through a small turbine here that helps spin this shaft, and this eases the workload of this tiny motor, which you can imagine uses a lot of energy. But with this recovery, they can save up to 50% on energy here. At the end of the process, the water still goes through a pH adjustment to make sure it's not too acidic or not acidic enough. Each set of these tubes is called a skid, and each skid is capable of desalinating 100 cubic meters of water per hour, or 100,000 liters of water per hour. Since they have 5 skids, the plant's capacity is 500 cubic meters per hour, or 12,000 cubic meters per day. It's no wonder that this is the largest seawater desalination plant in Brazil. The last step will be to store the water inside this giant water tank, what they call a buffer tank, so it stays at the right pressure and can then be distributed through the industrial water network of ArcelorMittal to Barão. And here is the final product of our journey today: desalinated water. Only those who give a thumbs up to this video will get to see me drinking water, okay? But to be honest, this water here isn't exactly drinkable. It's so clean that it doesn't have the necessary salts for us to be able to drink it. So to make it drinkable, we would have to remineralize the water. By the way, that's much smarter, more effective. It's economically viable for us to do desalination here in the industry, because then there's more water available for people to consume, for cities, for agriculture. I can't drink it all at once since that's unhealthy, but I can at least taste it to check if it's salty. Absolutely nothing. It doesn't have any taste at all.
The desalination process is a physical process, right? So you separate the salt from the water physically under high pressure. So we are returning the salt that is already present in nature itself. There are no chemicals in this process, right? Nothing that could cause any kind of impact.
In this return of brine to the sea, we're talking about 0.5 gram per liter of seawater. That 0.5 gram per liter figure is at 3 times the production capacity, right? It happens 500 meters away from the seawater return channel. So this 0.5 gram per liter doesn't have any effect on the ecosystem.
We're exactly at the point where the water reaches the sea, and there are several turtles that come up to breathe. They like it here because there's a lot of algae due to the warmer water. Let's see if we can show these turtles to you. Get this one. Look over there, wow. Since we're at a steel mill, I didn't want to leave without seeing a bit of red hot steel. So now, we're gonna see the process that turns steel slabs into coils. By the way, that also takes a lot of water too. Now that you've seen how much work it takes to remove salt from seawater in large quantities, I hope you'll think more carefully about how you use the water you have at home. It comes straight from your tap. Here, they've been doing all this, investing so that more drinking water is available for people. The technology that ArcelorMittal has developed is incredible. There are only a few places in the world that have it, but the coolest thing is that it remains in industrial use. If you want to know more about this project and several others that are happening here, like the thermoelectric plants that make them self-sufficient in electricity, take a look at their website and social media. Everything is in the description.